Hi, this is Mr. Sullivan, and now we're going to look at simplifying radicals when you have addition and subtraction. So here I have two radicals, and these are not perfect squares. So that means when I put this in my calculator, second square root of 45, I end up with an irrational number, a number that is not a whole number. So what I'm going to do first is I'm going to take these two numbers underneath the radical sign, and I'm going to do the prime factorization of these numbers. I have 45 and I've got 20. So the way I do this is I just try to break this number up through division. So 45, and I start with the number 2, the lowest number I can think of. 45 divided by 2, it's not a whole number, so I try 3. And I get 15. So 45 divided by 3 is 15. That means that 3 times 15 is going to give me 45. So I've just factored that, number 45. Now I'll take the number 15. I'm guessing it's not divisible by 2. Let's check out 3. And I get a 3 and a 5. So if I look at this, this means I have a perfect square factor because I have a pair of numbers. 3 times 3 is 9. So this square root of 45, I can pull out the square root of 9, which is equal to 3, from underneath the radical. And the only thing that's left underneath the radical is a 5. So that means that the square root of 45 is equal to 3 times the square root of 5. Now I'm going to take the number 20, and if I divide 20 by 2, I get 10. So 10 times 2 is 20. And then 2 times 5 is 10. And if you notice again, I have a pair. That means there's a perfect square. 2 times 2 is 4. So that means the square root of 4 can be pulled out. So I just take one of these 2's and I pull that outside of the radical. Now I found the square root of that. And what's left is 5. And if you notice, now I want to add these two things together, is this 3 times the square root of 5 plus 2 times the square root of 5. So this is just, these are like terms. So that means I can actually add these together. I have 3 square root of 5, so this is square root of 5 plus square root of 5 plus square root of 5 plus 2 square roots of 5. So it's plus square root of 5 plus square root of 5 again. So that means my answer is going to be 5 square root of 5. All I had to do was add my 3 and my 2 to get 5 times the square root of 5. And then you can just check your answer over here. Second square root of 45, close parentheses, plus second square root of 20, close your parentheses. I get this irrational number, and I put my answer of 5 second square root 5, and I get the same irrational number. That means that this is correct. Subtraction works in the same way, but this problem you have to be a little bit careful because I already have a coefficient in front of the radical. But this is, I look at this, I see this is a radical 2. That's already in its simplest possible form. That means I just have to take the number 72 and I have to break that up into its prime factors. 2 times 36 is 72. 2 times 18 is 36. 2 times 9 is 18. And then I have 3 times 3, which would give me 9. Right off the bat, I see a pair here, and I also see a pair here. And the only thing that's left is that number 2, which is convenient because it says this one has the square root of 2, so now what's going to be left here is the square root of 2, which means I can combine my answers. So I pull out one of these, I have a 3, and I pull out one of these, and I have a 2, breaking up those pairs, and all I have left under here is the square root of 2, and we're subtracting 3 square root of 2. So 3 times 2 is 6. Square root of 2 minus 3 square root of 2. And just like we did with addition over here, 3 plus 2 was 5. 6 minus 3 is 3. So my answer is 3 square root of 2. Okay, this is how to add and subtract radicals. Okay, just remember it's just like terms, and in most cases you're gonna notice that they're gonna simplify so that you can combine them, because that's what they're testing on this exam. Good luck with these problems.